real-time NeuroNavigator using SW Loretta that is now available inside of NeuroGuide. The way you activate it is you can either be recording from a individual in real time and evaluate the sources, or you can do playback. For now, we have the playback mode working, and what you do is you click collection, and then you go to real-time NeuroNavigator. I've already launched the NeuroNavigator, so I'm just going to bring it up so we can watch the EEG change at the surface of the cortex. And actually, it's in the sources of the cortex. And you can see the axial, coronal, and sagittal slices here, and you can navigate through the brain using these controls. You can rotate and evaluate different aspects of the brain in real time. You have the controls on the right that allow you to change whatever you want to go through the different aspects of the visual display. Here's the scalp surface electrical potential. You can also look at the Laplacian in real time. But right now, this is the electrical potential. This individual was injured in the right parietal region. You can control bands. In this case, we are looking at the theta band, but let's select, for example, there's alpha 2. So you can control different frequency bands that you want to look at. In the future, we'll be able to look at also different networks. So for now, let me remove the scalp map, and let's go to the volume view so we can get a better view of just the volume. We can resize that with the mouse wheel. We can eliminate the head model if we wish. We can put in the various slices. We can get rid of the cortex and evaluate these slice views that we also can change by these wipers here, or these controls, sliders. And that's the axial view. Here's the coronal view. And here's the sagittal view. And we also can bring the cortex back, and I'll bring the head model back. That kind of gives you a perspective, and then we can change the depth. We can, right now we're looking at the sources deep in the cortex, and now I'm moving all the way to the top of the cortex in 10 steps. It's dark here because we're now abutting to the dura where there are no sources, so we can step down from there and in 10 steps and go down deeper into the bottom of the cortex, where the sources are really smeared over that area. This is a low resolution electromagnetic tomography. You will not be able to localize sources in specific layers, but you'll be able to get a view of whether it's a deep or an upper source by the intensity of the currents that are seen at those different levels. Now, this is just current source density. There's no z-scores at this time. In the future, we will have real-time z-scores. We can also look at connectivity. For now, we can look at the center voxels, which are from the Brodmann areas of the center voxels. And in the future, we'll have the connections to those center voxels with the different networks. I'm going to remove the center voxels for now. We do have diffusion tensor imaging. I'm going to show you that. Right now, it's just the direction and not the z-score functional connectivity of the diffusion tensor imaging. But in the future, you'll be able to see the diffusion tensor imaging changing for the connectivity, not the current densities or current sources, but rather the connectivity itself. So you can see with the slices here that in real time, how these different sources of current are changing in real time. And even in the future, you could probably use this if you wanted for brain-computer interface. It's up to the individuals if they wish. So this is just a way to add another view to an individual who's visually examining the EEG traces and then wants to be able to add and augment that visual examination with a more statistical, intense visual examination of the traces for their own, to facilitate evaluation of the EEG using visual examination. So that is the new um, real-time release that is going to be available very soon. You can also look at the cortex here. I'm going to remove the slices and go down with the axial slice and then show how the diffusion tensor imaging actually, those slides, right now we're deep in the cortex. You can go up to the top. You'll see the diffusion tensor imaging. Fiber bundles disappear because they terminate or arise really from the lower levels of the cortex, layers 5 and 6. And we're right down there, layers 4, 5, and 6 here. And now we're going to go up to layer 1 up here. And some fibers are actually rising a little bit higher. In any case, that's a view of the real-time Navigator. We'll be developing more things with it in the near future. So thank you for watching.